Hello, Assalamu alaikum. Today we have started our chapter first from the book Fundamental of Electric Circuit by Charles Alexander and Matthew Sadiku. These are the following topics we have to cover in chapter 1: system of units, electric charge, current, voltage, power, energy, and circuit elements. System of units. We have 6 basic units. Length we calculate in meter, mass in kilogram, time in seconds, electric current in amperes, thermodynamic temperature in Kelvin, luminous intensity in candela. Then system of units: coulomb. Charge is measured in coulomb, and we denote it as C in this symbol. Potential as voltage V, resistance is in ohm, conductance is the reciprocal of resistance, and it's Siemens, or mostly we use mho. Inductance is in Henry, use symbol as H. Capacitance in farads, and symbol we use is F. Frequency is in hertz, force in Newton, and work and energy both are same thing. Energy is measured in joule, power in watts, magnetic flux in Weber, magnetic flux density in Tesla. Then prefixes: giga means 10 raised per 9, mega means 10 raised per 6, kilo means 10 raised per 3, centi 10 raised per minus 2, milli 10 raised per minus 3, and pico 10 raised per minus 6, nano, pico, and so on. Then first our article is electric charge. So charge is an electrical property of an atomic particle of which matter consists, measured in coulombs, and a charge on a 1 electron is equal to minus 1.602 into 10 raised by minus 19 coulomb, whereas on proton equal charge as an electron but with positive sign. Let's have an example. How much charge is represented by 4600 electrons? Charge on 1 electron is equal to 1 minus 1.602 10 raised by minus 19, and charge on 4600 electron is multiplying both, and the total answer is minus 7.369 10 raised by minus 16. Then we have to calculate amount of charge on 6 million protons. We know that electron and proton have same charge, but sign is different, and we use a hint over here. 1 lakh is equal to 10 raised by 6, and 1 million is equal to 10 lakh. This means that 1 million is equal to 10 raised by 6. A charge on a proton is equal to plus 1.602 into 10 raised by minus 19 coulomb, and 6 million charge on 6 million proton is equal to multiplying both charge on 1 proton multiplied by 10 raised by 6. Then the answer is plus 9.612 10 raised by minus 13 coulomb. Then the article is current. Current is rate of change of charge, means I is equal to dq over dt. The unit of current is ampere, charge is coulomb, and time is second. So the current the units are coulomb per second. If we shift the dt on the left side, then dq is equal to I dt. Integrating both sides, then we found a formula. Q is equal to integral I dt. Then we have a example 1.2. Total charge entering a terminal is given as Q is given. We have to find out the current at time 0.05 second. The formula is I dq over dt. We have to find the derivative of the given Q, 5t sine 4 pi t. It consists of two functions. One is 5t and another is sine 4 pi t. If we have to find out the derivative of a product, then we apply product rule. First as it is derivative of second plus second as it is derivative of first. Then the answer is I equals 20 pi t cos 4 pi t plus 7 plus 5 sine 4 pi t. Answer is in millicoulomb per second because charge is in millicoulomb and time is in second. We substitute the value of t in this equation. Then the answer is 31.42 millicoulomb per second. In the next practice problem, charge is given. We have to find out the current. The same formula is used. I is equal to dq over dt. We have to find the derivative of the given Q, then put the value of t in that. Then example 1.3. Determine the total charge entering a terminal between t is equal to 1 second and t equals to 2 second. If the current passing through the terminal, now current is given, we have to find out the charge from time 1 to 2 second. We use the formula Q is equal to integral I dt, and the lower limit is 1 second and the upper limit is 2 second. We have to substitute the value of I, which is 3t square minus t. Now we start the integration. 3 as a constant comes out of the integral. The integral of t square is t cube by 3 and minus integral of t is t square by 2. Then we have to put the upper limit minus lower limit, and the answer is 5.5 coulomb. Then another practice problem. Current is given. We have to find out the charge from time 1 to 2 second, and current is given. Its value is from 0 to 1. Its value is 4 ampere, and from greater than 1, its value is 4t square. Now we have to split the integral. From 0 to 1 its value is 4, and from 1 to 2 its value is 4t square. Then we find out the integral, and 4 is come outside the integral. Integral dt is equal to t, and upper limit is 1 and lower limit is 0. Then 4 comes out. Then integral of t square is t cube by 3. Then we have to put upper limit minus lower limit. The answer is 13.33 coulomb. Now come the topic voltage. Voltage is basically a potential difference. If if a unit charge is moved from a point to another point, certain amount of energy is consumed. The energy consumed is equal to dW divided by dq, which is equal to the potential difference or voltage. W is energy in joules, Q is charge in coulombs. And if VAB is greater than 0, means VAB is positive, then it is at higher potential. If VAB is less than 0, it means A is at lower potential. Then B. Now we have to find, we have an example on topic voltage. An energy source at a constant current means current is given 2 ampere for 10 second, means time is given 10 second to flow through a light bulb. If 2.3 kilojoule means energy, kilojoule means energy, is is taken off in the form of light and energy, calculate the voltage drop. Voltage drop is equal to work done divided by charge. Now charge, we have to charge is not given. We have to firstly find out the charge. Charge is the product of current into time. Current is given as 2 ampere, time is given as 10 second. Then charge is equal to 20 coulombs. Then voltage is equal to energy 2.3 kilo. Kilo means 10 raised power 3 divided by charge coulomb, 20 coulomb equals 115 volt. Then another practice problem 1.4, to move charge Q from point A to B requires 30 joules. Find the voltage drop VAB if Q is equal to 6 coulomb and part B Q is equal to minus 3 coulomb. In this practice problem, W is equal to minus 30 joule. We have to find out VAB. In first part, Q is equal to 6 coulombs. So V is equal to energy divided by charge. Then it is equal to minus 30 divided by 6 is equal to minus 5 volts. In second part, energy is equal to minus 30 and charge is equal to minus 3. Minus is cancelled with minus and answer is 10 volt. Now the topic is power and energy. Power is basically calculated in watts, and it is time rate of change of energy. This means that mathematically it is expressed as dW or dt. If we apply a chain rule means multiplying and dividing by dq, then we find that dW over dq is which we have recently studied is equal to voltage and dq over dt is equal to current. So P is equal to V into I. And other formulas are, if we substitute the value of voltage, then P is equal to I square R. If we substitute the value of the current in VI, then the formula is V square over R. And passive sign convention, we use negative sign for voltage for power supply and positive sign for power absorb. Law of conservation of energy states that the sum of power is equal to 0. It means that power supply is equal to power absorbed, and energy is ability of doing work is called energy, and it is measured in joule. And from the expression of power, we have to shift the dt on the right side, on the left side, then we integrating both side, we get power is equal to integral p dt. If we put the value of p, which is equal to vi into dt, now comes the watt hour. Watt hour is basically equals to 3600 joule. Actually watt hour 1 hour consists of 60 into 60 seconds, so this means the 3600. So that's why 1 watt is equal to 3600 joules. Now we have to start example 1.5. Find the power delivered to an element at 3 millisecond if current entering its positive terminal. Current is given as 5 cos 60 pi t and voltage as 3i, and in part B voltage is 3i di over dt. The formula is to find out the power is equal to Vi. Now insert the value of part A of voltage, which is equal to 3I. Then the answer is 3I square. Now substitute the value of I in over here. The answer is 75 cos square 60 pi t. Now we have to substitute the value of t, which is given in the question, 3 millisecond. The answer is 53.48 watts. Now in part B, voltage is given as 3 di over dt. Now we have substituted the value of voltage in formula of power IV, and we have to take the derivative of I and then product it with 3, then product it the value of I. Now we find the derivative of 5 cos 60 pi t. The derivative of cos is minus sign, then the angle derivative of the angle, which angle is 60 pi t. Then we have to solve. The answer is minus 4500 pi cos 60 pi t into sin 60 pi t. Then we have to find out the power at t is equal to 3 millisecond. Substitute the value of t, 3 millisecond, in above equation. Answer is minus 6.396 kilowatt. Then another practice problem 1.5, in which we have to find out the power at t is equal to 5 millisecond if and the voltage is given as V is equal to 2I, and in part B voltage is given as 10 plus 5 integral lower limit is 0, upper limit is t, I dt. The formula is I into V. Then we have to substitute the value of V, that is 2I, and then it become 2I square. Now we have to substitute the value of I, which is 5 cos 60 pi t. After solving it, we have to substitute the value of t, and the answer is 17.27 watt. Now we have to go to part 2. In part 2, first we have to solve out the value of voltage. We have to substitute the value of current in given expression. We have to find the integral, and then substitute the upper limit and lower limit. Then we have to multiply current with voltage, and then further we have put the value of t, 5 millisecond, and the answer is 29.7 watt. Now example 1.6, how much energy, this means that we have to find out the energy, does 100 watt, P is equal to 100 watt, power is given 100 watt, electric bulb consume in 2 hours, yani this means that time is given as 2 hours. Now we have two formulas. We have either we find energy in joule, or either we have find energy in watt hour. Let's suppose if we want to find energy in watt hour, so simply we have to put value of power, which is 100 watt, and time 2 hour, then it is equal to 200 watt hour. If we want the same in joule, then we have to convert that hour into seconds, and then the answer is 720 kilojoule. Now come toward the practice problem 1.6. A home electric heater draw 10 ampere I is equal to 10 ampere. When connected to a 115 volt outlet, means voltage is given as 115 volt. How much energy, means energy we have to find out. The energy is consumed by the heater over a period of 6 hours, means time t is equal to 6 hours. We have to find out the energy. Energy is power into time, where power is equal to I into V. I is given, V is given. We multiply both. Answer is 1150 watt. Then multiply it with time, 6 hours. The answer is 6.9 kilowatt hour. Now the last topic is circuit elements. Basically there are two types of circuit elements: active elements and passive elements. Active elements are those elements those who are generating, like batteries, cells, voltage source, current source. Passive elements are those which absorb power, like resistor, inductor, capacitor. Then we have dependent sources and independent sources. Independent sources are represented by circle, while dependent sources are represented by a rhombus like shape. In this figure, A and C are independent sources, while B and D are dependent sources. Further, if we consider in the dependent sources, if a certain voltage source depend upon a voltage in a given in any circuit, then it is called voltage controlled voltage source. VCVS means voltage control voltage source. Then it is written as CCVS, means current controlled voltage source. If a voltage source depends upon current of a certain branch, then it is called current controlled voltage source. Then voltage controlled current source. If a dependent current source depend upon the voltage of any branch, then it is called voltage controlled current source. Then CCCS means current controlled current source. If any dependent current source depends upon a certain branch current, is called current controlled current source. Now we have to find out power supplied and absorbed in example 1.7 in a given circuit, figure 1.15. We know that power supplied is positive and power supply is negative and power absorbed is taken as positive. If we supply a power, it means that a source, let's suppose a current source or a voltage source. For a voltage source, current always come out of the positive terminal, whereas in passive element, either it is resistance, inductance or capacitance, current always enter the positive terminal of that passive element. Now come toward find out the power P1. P1 is the power across 20 volt source. Now it is source and it is supplying power, and it is active element, so current is coming out of it. Then minus sign for power supply. Value of current is 5, value of voltage is 20. Minus 5 into 20 is equal to minus 100 watt. Now P2 is a passive element. Current is entering to the positive terminal. and power absorbed is equal to positive 5 into 12 is equal to plus 60 watt. Now come toward the P3. Here in P3 power is absorbed because it is passive element, and power is absorbing, power is equal to plus V into I, and current is also entering the positive terminal, so 6 into 8 is equal to 48, plus 48. Now come toward the P4. P4 is basically a current controlled current source, 0.2I, where a value of I is 5 ampere. It depends upon the current 5 ampere. Now P4 is an active element, and it is as a dependent source, and every source supplies power. So minus Vi, where I value of I is 0.2I, multiplied by its voltage. P4 is parallel to P3, so both have same voltage, which is 8 volt. Now we have substitute the value of I, and the answer is minus 8 watt. Now if we add all these, the answer should be sum of power is equal to 0, or if we equalize power supply is equal to power absorbed, then the answer is also same. Now come toward the practice problem 1.7. Compute the power absorbed and supplied by each component. Now P1 is basically an passive element, and it always absorb power, so plus V into I, and the voltage across it is 5 volt, but in every passive element current should always enter to the positive terminal, but in this case current is coming out of positive terminal, so minus sign is used over here. So P1 is equal to minus 45 watt, whereas P2 the voltage is 2 volt because it is source, and for source we use negative sign, so P2 is equal to minus V into I, and the voltage is 2 volt. For our voltage source, current should be go out from the positive terminal, but in our case current is entering the positive terminal, so minus sign, we use minus sign with value of current, that is minus 9, and the answer is plus 18 watt. Now come toward P3. Current is entering the source, but in actual for a source, positive current is going out from the positive terminal, and since it is a source, so we use minus Vi. Now we substitute the value of voltage, which is equal to 0.6 into I, and the value of current is minus 4. Now we have to substitute the value of I, which is given as 5 ampere. Now the answer is 12 watt. Now come toward the P4. Here in P4, current is entering to the positive terminal, and it is absorbing the power, as it is a passive element, so P4 is equal to plus V into I, 3 into 5 is equal to 15 watts. Now if we add up all these, the answer sum of all power is equal to 0, as per the law of conservation of power. That's all, and the lecture is finished. Thank you so much. Now come toward the exercise. We have an exercise problem over here, in which we have to find out the current, where a wave shape of or a graph of charge is given, Simply we have to find out the equation, uh, then we take the derivative of dq over dt to find out the current at t is equal to 1 millisecond, t is equal to 6 millisecond, and t is equal to 10 millisecond. And the equation comes from y is equal to mx plus c, where c is equal to 0, means y intercept is 0 over here. Change in y means dq is equal to 30 and dt is equal to 2, which is equal to 15t, and so the equation from time 0 to 2 is equal to 15t, whereas the value of charge from time 2 second to 8 second, its value is constant, which is equal to 30 millicoulomb. Then the wave shape declines or decreases, its slope decreases. Then we have to find out the equation, and the answer is minus 7.5t plus 90. Then we have to find out the derivative of 15 various values of q. 15t, if we take the derivative with respect to time, the derivative of 15t is equal to 15, the derivative of 30, which is constant, is equal to 0, the derivative of minus 7.5t plus 90 is equal to minus 7.5. Now current at 1 millisecond, from 0 to 2, its value is 15. So current from 1 millisecond at 1 millisecond is equal to 15 ampere. From 2 to 8, current is from 6 current from 6 millisecond at is equal to 0, whereas current at 10 millisecond actually there is a mistake. 7.5 value is from 2 to 12, so the current at 10 millisecond is 7.5 ampere. There, now we have an easy method to find out these equation. No need to find out the equation of 2-point form or a straight line equation. Just we have to I dq over dt, change in q divided by change in t. Actually from time 0 to 2 second, change in q is 30, while time is changing from 0 to 2, so I is equal to 15. Then from interval 2 to 8 second, the charge is constant, that is 30 millicoulomb, while the time is changing 6 units, 6 second, so I is equal to 0, while current from 8 while charge decreases from 8 to 12 second, that is decreasing, charge is decreasing from 30 millisecond to 0, while time is increasing from 8 to 12. The difference is 4. The answer is minus 7.5. Now we have to find out the current at 1 millisecond, then at 6 millisecond, then at 10 millisecond. Here is a mistake of the typo mistake. The answer is 15 ampere, 0 ampere and minus 7.5 ampere. Now come toward another practice problem of the exercise. Here we have to find out the total charge, and the wave shape is given as current flowing through a certain device. Current is 10t, means the slope is 10, while we use x-axis as time and vertical axis as amperes, and the value is 10t from 0 to 1 millisecond, whereas from 1 to 2 its value is 10 and the value is constant. Now we have to find out the charge. The formula is q is equal to integral I dt. We have to split this integral as its value changing from 0 to 1 its value is 10t, and from 1 to 2 its value is 10. Now integrate, and 10 we take 10 as common. The integral of t is t square by 2, whereas then we have to put upper limit minus lower limit. Then we take 10 outside the integral, and the integral dt is equal to t, upper limit minus lower limit, and the answer is 15 microcoulomb. Now we have an alternative method to find out the charge. Now the given wave shape has a area 1 and area 2. We have split the areas. We have to find out the area under the curve, or area of the triangle and a rectangle. Now first, area of a triangle is equal to half into length into width, and the second area is equal to length into width. Now the length is equal to 1 and the width is equal to 10. So half of 10 into 1 plus area of rectangle, which is difference of 2 minus 1 is that is equal to 1, and the height is 10. The answer is 15 microfarad. That's all. Thank you.